Hello and welcome to the Tuesday, November 14th, 2023 edition of the SANS and Storm Center's Stormcast. My name is Johannes Ulrich and today I'm recording from Jacksonville, Florida. Manuel today wrote a quick reminder that's, also one of my favorite topics, DNS logs and how important they are to detect intrusions. In particular, Manuel here is looking at the command control channels that often use sort of some custom made up names that the attacker registered. Now, yes, you have some sophisticated attackers that try to mimic specific well-known domain names and try to kind of fly under the radar that way. But quite often attackers are using essentially sort of random strings of letters and numbers in order to use these names then as a domain name for their command and control channel. That, of course, is not that difficult to spot. What Manuel here is doing is looking at the frequency distribution of letters, which prioritizes these random host names because they usually have few duplicates, and with that, is able in this case to spot pretty quickly and pretty easily a relevant domain name. Now, just one little trick here that Manuel isn't mentioning: if you do want to extract things like, here IP addresses and host names or domain names from a file like this, from a PCAP, if you don't have an existing tool, it actually T-Shark works really well for this if you just want to extract the relevant fields. Take a look at the -T and then fields option, and then you can just list individual fields. And then we have a somewhat concerning paper about the security of SSH from 4 researchers at the University of California, San Diego. The problem here is that it is apparently possible in some fairly common SSH implementations to actually derive the private key on the server. Having the private key on the server then would allow an attacker to launch a machine in the middle attack. Notice that it's the server private key, which typically does not allow you to log in to the server, but that key is used by the client to verify that it actually connects to the right server. That's sort of where the machine in the middle attack comes from. The main issue here is, and I refer to the paper for lots and lots of details, that if you are able to observe some faulty signatures that for whatever reason have an error in them, you can use those faulty signatures to then derive the secret key from the server with some reasonably low effort. They collected a good number of SSH connections from their university network and found many of them to be vulnerable and being able to derive the keys. 2 manufacturers sort of stuck out, Sykcell and Cisco. They were both contacted and they should have fixes deployed, or actually have had fixes out there for quite a while. But again, refer to the paper for all details. There's lots of subtleties here to it. Also, RSA is the particular algorithm being vulnerable here. If you're using an algorithm other than RSA, like elliptic curves or such, you should not be vulnerable to this particular issue. Now, the tricky thing, of course, is then what to do if you find yourself to be vulnerable. Well, in that case, you probably want to change the server secret keys. That, of course, requires also that the clients will accept the new key. That's always sort of a little bit one of those things where people tend to be sloppy when it comes to SSH. And you're definitely not affected by this vulnerability if you click OK anyway whenever you see sort of a bad SSH signature. Then we do have some Juniper or JuneOS vulnerabilities that are being exploited in the wild now. These vulnerabilities were originally patched mid-August, but are now actually being exploited. And this includes one vulnerability in particular with a CVSS score of 9.8. That's CVE 2023-36845. This is a PHP external variable modification vulnerability. Well, that's it for today. Thanks for listening. Thanks for subscribing, and talk to you again tomorrow. Bye.